everyone. Today's lesson is going to be about evaluating functions. So when we're evaluating functions, we take a function, we plug in a value, and then we simplify. So if we look at this first example, f of x equals 2x minus 3. Here we have a function. That means whatever input we have, x, we're going to multiply it by 2 and then subtract 3. So we want to find f of 4. In other words, find f of x when x equals 4. So we rewrite this by saying f of 4 equals 2, and everywhere there's an x, I'm going to plug in 4. So here's an x, so I'm going to put parentheses 4 and then put minus 3. And then we simplify. So f of 4 equals 2 times 4, which is 8, minus 3, and f of 4 equals 8 minus 3, which is 5. So my solution to f of 4 is 5. In other words, when x equals 4, f of x equals 5. So we can write the point 4 comma 5 to represent our solution. Here we have example 2. Example 2 is f of x equals x squared minus 3x, and we want to find f of negative 3. That means x is equal to negative 3. We're going to replace every x with negative 3. So we have f of negative 3 equals, and here's an x squared, so I'm going to plug in negative 3, and don't forget the square. Minus 3, there's an x, so I'm going to plug in negative 3, and now we simplify. F of negative 3 equals negative 3 squared is a positive 9. Then we subtract negative 3, and then we multiply it by a negative 3. So minus 3 times negative 3, that's two negatives. That's going to be a positive. And then 3 times 3 is 9. So we get f of negative 3 equals 9 plus 9, which is 18. So this means x equals negative 3, and f of x equals 18. So we get the point negative 3 comma 18 as our solution. Here we have example 3. Example 3 is f of x equals x squared all over x minus 15. So we have a fraction, and we need to find f of negative 5. So we replace all of the x's with negative 5. So we're going to say f of negative 5 equals, here's an x, so we're going to put negative 5 in parentheses, and then we're going to square it because the x is squared, over x minus 15, so negative 5 minus 15, okay? So now we're going to simplify. So f of negative 5 equals negative 5 squared is 25, over negative 5 minus 15 is a negative 20. So now we have 25 over negative 20. We can reduce this by 5 on both the numerator and denominator. So if I divide 25 by 5, that's going to be 5. And if I divide negative 20 by 5, that's going to be negative 4. So f of negative 5 reduces to negative 5/4. Okay, so this means that x equals negative 5 and f of x equals negative 5/4. So we can write the point negative 5 comma negative 5/4 as our solution. So we talked about plugging in a numerical value into a function, and we get a numerical value after we plug that in. This time we're going to plug in an expression. So we want to find f of x, which in this case equals 3x minus 1, and we want to find f of a plus 3. That means we're going to replace x with the expression a plus 3 and then simplify. So I'm going to have f of a plus 3, and everywhere there's an x, I'm going to put a plus 3 in parentheses. So this is going to equal 3, and then we're going to put a parentheses and a plus 3, because here's 3x, so 3 times my x, which is a plus 3, and then we put a minus 1. So now to simplify, we need to distribute the 3 to the a and to the other 3. So we get f of a plus 3 equals 3 times a is 3a, and 3 times 3 is 9, so we're going to add 9 and bring down the minus 1. In the next step, we have f of a plus 3 equals 3a, and then 9 minus 1 is a positive 8. So we get 3a plus 8, and that is my result. So f of a plus 3 equals 3a plus 8. Now, because this isn't a value, we don't have to put an x comma y value. We can leave it like this. Okay, in this next example, we have f of x equals x squared minus 2x plus 1. So whatever input we're putting in, we're squaring it, then we're subtracting 2 times the input, then we're adding 1. And we're going to find what this function equals when we plug in for x 2a minus 1. So we're going to write f of 2a minus 1 equals, here's an x, so in parentheses we're going to put 2a minus 1, and it's squared, so we're going to put a square. Minus 2, there's an x, so we're going to put parentheses 2a minus 1, and then there's a plus 1, so we're going to bring down plus 1. So now f of 2a minus 1 equals, since this is a square, we're going to have to write it twice. That means 2a minus 1 times 2a minus 1, and we don't need the square anymore. Here we have negative 2 times 2a minus 1. We can distribute the negative 2 to both of these values. So negative 2 times 2a is a negative 4a, and negative 2 times negative 1 is a positive 2. Then we bring down the plus 1. Now here we need to distribute. So in the next step, we're going to say f of 2a minus 1 equals, and we're going to distribute 2a to 2a. Well, that's going to be 4a squared. Now we're going to distribute 2a to negative 1. That would be minus 2a. So now we have to distribute the next number to both of these values. So we're going to distribute negative 1 to 2a, which is another minus 2a. And then we're going to distribute negative 1 to negative 1. Negative 1 times negative 1 is a positive 1. So that's the expansion of 2a minus 1 squared. See, we expanded it into two terms that we're multiplying, and then we used the distributive property to get 4a squared minus 2a plus 1. Now, the rest of this is just going to come down. So we're going to say minus 4a plus 2 plus 1. And now we're going to combine like terms. So we're going to say f of 2a minus 1 equals 4a squared. I don't have another a squared, so we're just going to bring down 4a squared. Now the a's. I have a minus 2a, a minus 2a, and a minus 4a. Minus 2, minus 2, minus 4 is a minus 8a. Since they all have a's, we bring down the a. And now the only thing left are the numbers. I have 1, 2, and 1. 1 plus 2 plus 1 is 4, so we're going to bring down plus 4. So f of 2a minus 1 equals 4a squared minus 8a plus 4, and that is our result. Okay, we're down to our last example. Our last example is f of x equals x squared over x plus 3. So in this function, our input is squared in the numerator, and then in the denominator, we take our input and add 3 to get our output. So what we're going to find this time, we're going to replace our input x with the expression a minus 1. So f of x becomes f of a minus 1, and we plug it into this expression. So x squared is going to be a minus 1 squared over x plus 3. So that's going to be a minus 1 plus 3. So now we need to simplify. In the numerator, I have a square. So we're going to say f of a minus 1 equals, and we're going to expand it into two different multiplications. So we're going to say a minus 1 times a minus 1. That's what a minus 1 squared means. Now in the denominator, nothing's really happening around the parentheses, so we don't really need the parentheses. We can say a minus 1 plus 3. Now in the numerator, we're going to have to distribute. We're going to distribute a to a and a to negative 1. So that'll be f of a minus 1 equals a times a is a squared. a times negative 1 is a negative a. Now we go to the next term, which is negative 1. We're going to distribute negative 1 to a. So negative 1 times a is a negative a. Then we're going to distribute negative 1 to negative 1. Negative 1 times negative 1 is a positive 1 over a, and then minus 1 plus 3 is plus 2. So now we can combine like terms, and we can say f of a minus 1 equals, there's no other a squared in the numerator, so we're just going to have a squared. Then we have minus a and minus a. Well, that's going to be a minus 2a. Bring down the plus 1, and then we're left with our denominator of a plus 2. And this is about as far as we can go. So f of x equals x squared over x plus 3, finding f of a minus 1 gives us the expression a squared minus 2a plus 1 all over a plus 2. So this is our final example here. Well, I hope you enjoyed today's lesson on evaluating functions. We went over how to evaluate when we plug in a number and when we plug in an expression. Be sure to practice as many problems as you can. I hope to see you all next time.